Alright, so we're flipping 4 fair coins. That means they should each have each side. Oh, that means it should be a 50-50 flip, theoretically. So what's the theoretical probability that all 4 will come up tails? Well, the key on this is we're not just flipping the coin one time. Uh, Whenever we have independent events, and we have to assume that because I don't think in the universe, if you roll a heads, that's one thing about the lottery, right? If you choose some numbers today and they don't work, that doesn't mean you got to change your numbers. You could just keep playing the same numbers because you're still drawing without replacement, right? Lottery numbers can repeat. So we're talking about independent events. And independent events, if they're assumed to be independent, if independent, we can use the multiplication rule here, which means since flipping a tails on the first flip is a half, flipping a tails on the second flip is theoretical probability of a half. Theoretical 1/2 is a half, and then again 1/, the deuce here. That's flipping all 4 tails, right? That's all the same numbers. So that means, and what does it want? Simplified fraction. So that means we do this right here. Get our Desmos to give us a simplified fraction. So 1/16. Alrighty. So what's the theoretical probability the first toss is heads and the next 3 are tails? Ironically, we could do this simulation, but like flipping a tails is the same theoretical probability of flipping a heads, so that should be 1/16 as well. Alrighty. And so see, they're independent, right? So now we got a friend flipping a coin 50 times, and they tell us that the probability of getting ahead is 40% because he got 20 out of 50. Is this referring to an empirical or theoretical? That's empirical because he flipped it 50 times, right? This is an example of empirical, so it's either C or D. Based on an experiment. Theoretical would be based on the relative frequency, I suppose. Anyway, we got that. Short run relative frequency. Remember the law of large numbers. The law of large numbers is in the long run. So there's your economics 101, macroeconomics. Short run, long run. Short run, long run. You'll see a difference when you look at your economics. That was 21. Let's go on to the next one. Always remember to click save. It should automatically save, but especially in the homework, make sure you're saving. Definitely save on the quizzes. So this appears to be a repeat. Yes, I don't see any difference in those questions, so that was just a repeat. It's just different. We might as well do it here because it's asking slightly different questions. But again, remember, when you're working on these things, it's open book, open note. So we should be able to open up, and I lost it, I guess. Let me get D2L back open. let me go back into that content that right now I was saying is in week 4, and I saw random, so I put it there. Standard deck layout. Let me split my screen to that and this over here. What it's saying is drawing a niner. See if there's any difference. I don't see any replacements. Looks to be very similar, only it's going to take a different approach. So you might end up with a couple of different variations of this problem here. So be prepared for both. Let me bring in the deck. The probability that the card is a niner. So we would go to 9 here and see there's 1, 2, 3, 4 niners. That's 4 niners out of 52. Okay, if we don't want to use our brain on simplifying fractions, because we're focused on statistics, 4 out of 52, that reduces to 1 out of 13. Right? That should be the way we did it. Yes. So again, the probability that it's a red card. Remember, that's half are red, half are black. So we could just simply, since we've already practiced this one a couple times, we know that it's 1/2 as a reduced fraction. And then a diamond, so we go to our standard deck of cards. We're looking at our diamonds. There we are. Sorry. So we've got 13 diamonds. So that's out of 52. That's 1/4, if you remember, right? 13 times 4 is 52. So that should be 1/4. And is a non. Okay, this is interesting. There's a couple here. Let me try to do this in an interesting way. Remember earlier we found that there was 9 face cards. So let's find the complement of a face card using Desmos. The complement of that would be 52 minus the face cards. So there should be 43 non-face cards. So we should get a 43 out of 52. 43 should be prime. Oh no. 43. Oh yeah, I thought it was prime. It's not going to reduce. It was just giving us the decimal. So see that one will not reduce. It's going to be simply 43 out of 52. Let's check our answer. Wait. Non-face card. How have I misinterpreted that? Oh, there's 12. My bad. Let me get rid of that one. My bad. Sorry. There's actually 12. My bad. So that means it should be 40 out of 52, which will reduce to 10 out of 13. So we need a 10 up here. And we need a 13 right here. That should be the right answer. There we go. So there's another mistake. You can chalk it up. It's misreading the information. So now let's go to this next one here. We'll make it the whole screen. And we'll probably end it. Well, let's see what we got. Suppose a person is chosen at random. Using your knowledge about the world, decide whether if a person has blue eyes, in the event that they're left-handed, is independent or associated. I don't think there's any studies showing that more left-handed people have blue eyes. So they should be independent. So the associated ones would be out. Independent means it does not depend. Notice this says depend, this says does not depend. This is that whole conditional probability concept. All right. Here we go. When two dice are rolled, is the event the first die shows a number greater than 1 on top? Independent of the event, yes. One roll should not affect the second roll in the universe and the rules of physics that we have, that we're dealing with right now. It shouldn't affect it, but like, you might be in a different universe like Leonardo DiCaprio was in that movie Inception. But we're going to assume that we're in this universe, so they should be independent. So A is wrong, D is wrong, it's one of these. See the does not affect part. So even though this does appear to be a mutually exclusive concept, that's not necessarily what we're talking about, because it's asking about independence. So it would have to be that one. Okay? So in this here, 25 is easy. We can do this one pretty easily. So which one, if we were based on 10,000 rolls, which would be the relative frequency, basically a percentage or a proportion of all outcomes to predict the probability? We did it at 10,000 times. So this should be converging about the probability here. The probability of we're rolling a dice, so it's 1 out of 6, right? And remember, as a fraction, that's 1/6. So that's got to be it. So A is the 10,000 rolls. And is that all we're asking? I guess so. We've completed it. So next I'll do the second part of this. I'll try to focus on week 5 and 6, what we're coming up on. I might drift a little bit over into week 7. But anyway, that's what we're dealing with. That is the practice final exam that we have so far. Some of these will be withdrawn. None will be added. But if you study these, you should be good on the test. You just may not see some of these.